Hello community! Yesterday, OpenAI showed us Sora. Finally, we can create videos from a text prompt. And yesterday, Google introduced Gemini 1.5 Pro with 1 million token length. But do you know what? 2 days before this, on February 13, the most important event happened that triggered those two events. Do you know what happened? UC Berkeley. Let's start at the beginning. August 28, 2023, we have a new publication, a Blockwise parallel transformer architecture for LLMs. Amazing. And they tackle here the quadratic self-attention and the large feed-forward network of the transformer. And they say, hey, how can we find a solution for the quadratic complexity given the context length? And they found a solution. They included also the feed-forward network. So not only the flash attention, which uses a block attention computation for the self-attention softmax functionality, but they now could include the feed-forward network. And they named the new methodology the Blockwise Parallel Transformer, BPT. If you want to understand it, this is it. It's just one paragraph. Have a look at this. It's rather simple. And here on the right side, I put you here the flow diagram. A beautiful solution to include attention and feed forward. If you want to see the code, this is it. Look here. This is the Blockwise attention code. And here you have the Blockwise feed forward network. This is it. So UC Berkeley proposed the Blockwise parallelization approach. Yeah. It is pure parallelization. So it is pure compute power to reduce the memory requirement of the transformer, the quadratic complexity. So we don't need Mamba anymore. We found a solution. Enables processing long input sequences while maintaining or improving here the performance. And the author said, hey, we thank Google TPU Research Cloud. So and they did this on 64 TPU version 4. Version 5 was not available at the moment. And they said, hey, some months later, our primary objective is to eliminate the memory constraints imposed by the individual devices by efficiently distributing here the longer sequences, the longer context length of the LLMs across multiple hosts without adding overhead. And to achieve this goal, Berkeley proposed here an enhancement to the already Blockwise parallel transformer framework. So what they did, they gave us ring attention, November 27, 2023. And they said, hey, we thank Google TPU Research for granting us access to the Google TPU parallelization nodes. So how did they do this? Simple. They reorganized the compute. And they put simply a ring of hosts, and each host holds one query block, and the key value blocks traverse through a ring of hosts for the attention and the feed-forward computations. With this simple but beautiful idea, yes, highly parallelized, you need a lot of compute infrastructure. Forget that you can do this on a simple single GPU. They found a solution, and here they also showed you here the original transformer block by block computation. What they succeeded in was to allow the context length to scale linearly with the number of devices while maintaining the performance, eliminating the memory bottleneck imposed by doing this on a single GPU, on an A100. Through extensive experiments, yes, we demonstrate its effectiveness, enable training sequences that are up to device count times longer than those for prior memory efficient transformers, and now exceeding a context length of 1 to 100 million tokens without making any approximation to the attention mechanism. This is beautiful. Look at this. And they give us here to 500,000 to 500,000 token context length. They show us the accuracy, and you see here in green the ring attention of a 13B model. It is almost flat, so almost perfect accuracy. And at this time, they were happy that they could here have a better performance than Claude had at the time with 100K, 200K And now they are at 1 to 100 million. And then on February 13, finally this happened. And I hope you did not miss out on this very particular beautiful archive paper. Because what UC Berkeley gave us in an open source is a highly optimized implementation here of the ring attention, mask sequence packaging, other key features for training here, millions length multi-modal sequences. And they not just gave it the code, but they also pre-trained and fine-tuned it. So we have now a fully open sourced family of 7 billion free trainable parameter models that are capable of processing text, documents, and videos with over 1 million tokens. And this is open source, and I show you the link. You can go there and you can try it yourself. And I tried here the JAX implementation. It's amazing. So what did they achieve just 3 days ago that forced here Gemini and OpenAI to come out 2 days later? Look what they said. Hey, we have a 1 hour video, and then have a question answering over a video that is 1 hour long. And GPT-4 fails. Gemini Pro fails. Video Lava fails. But our model, yes. Another test. GPT-4 fails. Gemini Pro fails. You get the idea. So they showed with their methodology, they could succeed where all the other models failed. And 2 days later, and I'm absolutely sure this is just a coincidence, OpenAI and Google came out and said, hey, we have our models too. But let's stay with UC Berkeley, because their training is amazing. Look, stage 1 was LLM context detection. Stage 2 was vision language training. Look what they did. Look at how we have a specific test here for the accuracy, the needle retrieval here. And they go to a context length to 1 million token. And they show us the score of the needle test, if you want. And at 100%, we have 100% accuracy. Absolutely fascinating. 1 million token. Open source, free. You can download it immediately, right now. What they also did is text to image generation. We have now a new open source program. You put in a text and the image is generated for you, maybe on your local machine. We have image-based conversation. But the nicest thing is, of course, an open source and free text to video generation. So your prompt generates a short video. And now I know a pure coincidence that 2 days later OpenAI came out and said, hey, we have this. Isn't this beautiful? So short sidestep to Gemini Pro 1.5, because I have to tell you, if you look here at the technical paper, here you have the report, the PDF link, go there, really interesting to read. Of course, now I have to tell you, Google has resources, amazing. And they officially state here that they trained the 1.5 Pro here on a multitude of 4,096 chip parts of Google TPUs. So I think with this pure compute power, I think the quality or the performance, of course, this I think is gonna be amazing, because just 1 day after the announcement, I have no access to 1.5 Pro and the public has no access to this. So we are just hoping, but you can download here the open source version and optimize it maybe yourself. And here, a second, where Google advances beyond UC Berkeley, they also included here an audio training. So they have not only text, by the way, you see there are some mistakes here in the text haystack test with 1 million token, but never mind. So UC Berkeley, I think they did a great job. And they have the video haystack and they have the audio. So Gemini has here really text, video, and audio is missing by UC Berkeley for the moment. Just happened 2 days ago. Who knows what's gonna happen next week? Hint. And of course, it's a very nice example here from the official Google paper. It's beautiful. Look, you just upload a book with more than 1,000 pages. Then you draw something and you ask, hey, on what page is this event that I depict here in my graphic? And then, as Google states here, this is the original Google documentation, they say, yeah, on page 1099, hey, took the 2 silver candlesticks. So you see, it is gonna be amazing. But if you do not want to wait for Gemini 1.5 Pro, and if you do not want to pay Google AI, here's the code for you. Download it now. At first, if you want to go with the traditional ring attention code implementation, here, this is the GitHub for you. Beautiful, have a look at this, but I suppose you are interested in this one. GitHub Large World Model LWM. And you see, just 2 days ago or 13 hours ago, here you have the code. And you know, it's Apache 2 license. Go have a look at it. It's beautiful. I'm currently experiencing here the JAX version, but you know what? There's also a PyTorch version for you. So those are the models you can download. You have a context window of 128K, 256, half, and a full million. This is here for language, and then you have here 3 vision language models. But of course here, you need compute power, you need JAX computation. We are here in pure parallel processing. And you know that the day would come where a single GPU, even if it's an A100 or an H100, is not enough. If we go to videos, we need heavy parallelization. And yeah, if you have 4,000 pods in parallel like Google, yeah, of course. Wow, it would be so nice here to have access to the Google infrastructure for free, but unfortunately, yeah, this is it. I hope you have got some idea how exactly this is happening. If you ask me, did Google here, no, in Gemini 1.5 Pro, did I find here the ring attention mentioned? And did I find the authors of the ring attention mentioned? In my reading, I did not find the reference. So maybe Google is using here a different methodology. But given that they talk from about 1 to 10 million tokens, I think in any way, ring attention is there for us today, free of charge, open source. The model is ready for you to download, experience it. Or you wait till Gemini 1.5 Pro will become available for the public. You have to pay Google for the Google AI Studio environment plus. But of course, you expected this. But I think now is an absolute interesting time because now finally we go here to synthetic video generation. And as I showed you, you can understand the mechanism and you can have access to the code in the open source community, which is amazing. And therefore, hey, UC Berkeley, great job and thank you. I hope to see you in my next video.